All right, I want to thank the organizers for including this paper to the program. This is joined with Andre Fratkin, also from BU, and Chiara Ferronato from HBS. I'm Tesary from Boston University. So in this paper, we seek to understand the impact of dark patterns in the process of data collection. And in particular, we want to see whether these implementation of dark patterns affect consumers' data sharing decisions. And also, we want to see how the deployment of these dark pattern practices affect websites' ability to compete for consumer data. So let me start by describing what exactly we mean by dark patterns, because this is actually a term more commonly used among policymakers and also by computer scientists. In economists, we often refer to it as nudge. So by dark patterns, we mean the design elements that nudge consumers towards an action that is desirable to the firm. Well, from our perspective, we are actually kind of like ex ante not taking a stance saying that this is necessarily bad for consumers, because nudge could be good or bad. Now, on the right-hand side of the screen, you see an example of these dark patterns in practice. So this is from Stack Overflow. Some of us may already be be quite familiar with this website. So here you see that, well, this is a cookie consent banner that uses multiple dark patterns to maximize the possibility that consumers are going to say, I accept cookie sharing. First of all, they hide the reject all from the main screen. They also use different color schemes for accept and customize settings. And lastly, they rank the accept all on top just to maximize the possibility that someone is going to say yes. Now, design patterns like this are incredibly common. Existing papers in the CS literature show that after GDPR, more than 50% of the EU websites use some sort of dark patterns to maximize the possibility to collect consumer data. And in the UK, this number is even more drastic. And the prevalence of these design patterns have attracted regulatory attentions across the board. For example, German authorities and also FTC here in the United States all have taken measures to target the the practice of using dark patterns. Now, importantly, I want to mention that policymakers still seek to understand the impact of these design patterns to consumers and also to competition, which is demonstrated by this quote from one of the FTC commissioners back in 2021 in one of the workshops on dark patterns. And this is exactly what we seek out to answer in this paper. So basically, we want to answer these three questions. First of all, we want to see how effective are various dark patterns in affecting consumers' data sharing decisions. And we are going to go from here and try to understand, well, what is the competitive impact of these practices? And in particular, we want to see whether consumers respond differently to these dark pattern influences when they are visiting popular, familiar websites versus when they are visiting niche and lesser known websites. I think one way to reframe this question is usually in digital markets, we see a data-enabled incumbent advantage, and we want to see whether the presence of these design patterns will actually exacerbate or would they actually alleviate this type of data-enabled incumbent advantage. And the last question, we want to see what is the impact on consumer welfare, and we are going to try to simulate the we try to calculate the consumer surplus under different data sharing policies, so kind of UX designs, and see which one will maximize consumer welfare and how does that compare to the status quo. Now, to answer these questions, we would need an experiment, and our experiment is enabled via a customized browser extension. Now, this extension allows us to randomize these dark patterns when consumers organically browse the website. We are going to do that for 7 days, and we are going to measure the effect of dark patterns on consumers' data sharing decisions across different websites for any given consumer that are enrolled in our study. So there are two advantages of this design. First of all, we are measuring dark patterns effect when consumers are organically browse the website. So that gains us some external validity compared to a typical lab study. And second, we are also able to observe the dark patterns influences across a wide range of websites, so across different domain ranks and site categories. And we believe that this is the key for us to understand how dark patterns potentially affect websites' competition for consumer data. All right, so let me give you an overview of how the experiment looks like. Our experiment contains two different stages. One we call the survey phase, which lasts for 20 minutes, and the other is the organic phase, which lasts for 7 days. For the survey phase, we will ask our participants to visit 20 websites that we pre-specify, which vary in domain rank and also in website category. And here we are going to randomize the design of the banners across the consumers and across websites. And then when they go to the organic stage, they can browse any website as they normally would. And in the second stage, we are going to randomize the design of the banners as before, but also we are going to randomize the frequency of the banner because, well, in our paper, we also want to see kind of whether there's an influence of fatigue. For the short talk, I'm going to ignore that today, but it's in the paper. Consumers' choices are going to be incentive compatible because we are integrating our extension with another extension called auto consent that allows us to pass on consumers' decisions back to the websites. Now, this is not 100%, but with high probability, and we told the participants that we try to enforce their decisions. Another detail about the experiment I want to mention is that we use survey to measure consumers' characteristics as well as their beliefs associated with different data sharing decisions. One thing that you will see later in the data is that sometimes consumers, instead of making an explicit data sharing choice, they would just directly close out the cookie consent banner. And that would mean that they disengage with the choice. And one thing that we ask for is, what do you believe will happen when you close out the consent window? You will see that this turns out to be a very important component when we are simulating consumer surplus under different types of kind of dark pattern and user interface designs. In total, our experiment have more than 600 participants recruited via Prolific that generated valid data points, and our data also contains around 16,000 domains with our banner pop-up. All right, so let me talk about the treatment. We have 6 different treatments that allow us to separate the effects of 3 common dark patterns. And these dark patterns are actually exactly the as you saw in the Stack Overflow example. So we have the deliberate obstruction. And the primary example of this is hiding the option that you don't want consumers to choose from the main screen. The second one, reordering options, would mean that while you ran the, for example, the accept all on top. And the last one would mean that while you are going to gray out the options that you don't want the consumers to choose. Now, I would like to invite you to categorize these 3 dark patterns into 2 different buckets. If you think about deliberate obstruction, it mainly changes consumers' decisions by increasing choice friction. On the other hand, reordering options and graying out, they mainly change consumers' decisions by manipulating the visual salience of the options. We think of them as belonging to different mechanisms, and in our structural model, we will basically treat them as such and take into account that while these mechanisms are different. Here is an example of what we call the quote-unquote neutral banner. So this is our baseline group where we are trying to observe consumers' decisions when they are not influenced by the dark patterns that we are testing. So here, what you can see is that, well, our design is going to put all the options in the front. We are not hiding any options. They use the same color scheme, and we are going to rank the cookie settings on top. Now, from here, a consumer would have, well, several options. They can click accept all, they can click reject all, they can close out the consent window. They can also click into the cookie settings. Now, if they do that, there are different subcategories of the cookies. They can choose to share or not to share with the website. If they leave it as is and click accept selected cookies, then that would be equal to reject all. Alternatively, they can also one-click select all. Again, click accept selected cookies. That would be the same as accepting all cookies. Now, let me mention that while these 4 options, accept all, reject all, closing the windows, and granular choices. These 4 options are always available when a consumers interact with the website, no matter which treatment they are in. The main difference is how easy or how hard it is, to choose one of these options, and that would be a function of these dark patterns. So for deliberate obstruction, we are going to hide the reject all from the main screen, as you can see here, or we are going to have a pro-privacy version of the same design, which is going to hide the accept all. For reordering options, we are going to rank either the accept all or the reject all on towards the top. Now you may ask, well, why are we including a pro-privacy version of the design? Now, if you look at treatment 5, for instance, this is actually adopted by Apple's ATT. So we think that, well, it might be helpful to kind of test out the impact of some of the pro-privacy versions of these design patterns. For the last one, we are simply going to gray out both the reject all and the cookie settings. Both of them are less desirable from a website's perspective. All right, so that's the design and the of the experiment. So from there, let me show you how consumers' data sharing choices look like at baseline when they are not affected by the dark patterns. So one thing that we see is that, well, when they're not influenced by any dark patterns, they actually choose to accept cookies quite frequently. And this number is 66% during the survey stage and 60% during the organic visits, which are represented by the dark blue bars here. So this is actually a bit surprising. I would actually expect the numbers to be quite a bit lower. One difference, if you want to compare the survey phase decision and the organic decision, is the frequency of closing out the window. And that number grows from 8% during the survey stage to 23% during the organic visits. Now, you may ask, well, what do consumers believe when they close out the window? Our NI survey shows that 60% of our participants believe that closing window equals rejecting all cookies. And I want to mention that, well, our consumers are recruited from the United States. And if they believe so, this is actually inconsistent with what the US websites are actually doing, because as of current, if you close out the consent window and not making any explicit choices, by default, the websites are going to collect all of your cookies. So this represents a gap between consumers' belief and what is actually happening. Now, we also find that consumers on average accept more cookies from familiar sites and more cookies from popular websites. So this is a regression table that summarizes the type of specification where we include website characteristics as covariates along with the dark pattern treatment dummies. And the 2 characteristics that we include, one is what we call as a pre-experiment visit. This is an indicator that equals to 1 if a consumer has visited the website 2 weeks before the experiment. And the other one is the log domain rank. So if you look at the table, you will see that, well, if this is a website that the consumers have visited before, they are more likely to accept all cookies, less likely to reject all during the survey stage, and less likely to close the windows during the organic stage. If you look at the the data sharing inclination across domain ranks, the pattern is somewhat similar. Now, one difference that I want to mention is that, well, during the survey stage, consumers are less likely to share cookies to niche websites. If you look at the organic stage, that difference disappeared. We think that one potential explanation for this differences in the survey versus organic phase is because consumers choose what website they visit during the organic stage. So they may already be choosing websites that they trust more. And if this is true, whether this is a popular or niche website may matter less to them during the organic stage. All right, and so let me also show you the effect of the dark patterns, and I'm going to start with the deliberate obstruction. For a clean comparison, I am going to compare every pair of the treatments where the visual salience manipulation is hold fixed, and the only difference is whether I hide a certain option or not. So I'm going to compare the accept settings with the accept reject settings, and the reject settings with the reject accept settings. So what you are seeing here is that if I hide an option from the main screen, the choice for the hidden option is going to decrease by 70% compared to the baseline rate. And this is true whether we are hiding the reject all or the accept all. Consumers are going to substitute their choices towards the other options, but most likely they are going to substitute towards closing the windows, which is represented by the gray bars in this figure. And to me, this shows the very potent influence of the choice frictions, because it shows that when you hide an option from the main screen, instead of kind of like going to the settings and make my preferred choice, I would more likely to simply close the consent window and not make any choice at all. In comparison, if we look at the impact of the visual salience manipulation, we see very small effects. And this is demonstrated by the fact that, well, if we compare across different treatments that perturb the ranking, and when we compare the design where some of the options are grayed out versus the version that does not do the graying out, we see very small changes in the choice shares. We also want to understand the effect heterogeneity across different websites. And in particular, we want to test whether the dark patterns would exacerbate the differences in the consent rate for the popular and familiar sites and for the niche and lesser known sites. So to achieve that goal, we are going to specify a linear model where the data sharing decisions are going to be the outcome. On the right-hand side, we are going to interact the dark pattern treatments with the log domain rank and the pre-experiment visits, the two websites that I showed you earlier. And for the short talk today, I'm going to kind of include a simplified specification where I only interact the kind of deliberate obstruction with these two side features, but there is a more complete version in the paper that you can check out. So here are the estimates. Let me first mention the third row that I'm highlighting here, which shows the baseline inclination to share with the familiar sites. And this is consistent with the regression table that you saw earlier. If I'm interacting with the familiar sites, the consumers are going to be more likely to accept our cookies, less likely to reject, and less likely to close. If, on the other hand, you look at the interaction term, so interestingly, this is either insignificant, or if they are significant, they actually goes in the opposite direction. So that suggests that, well, the dark patterns are not increasing the inclination to share more data with the familiar sites. If anything, if you're taking the significant portion of the coefficients seriously, they actually seem to suggest that they might alleviate the inclination to share more with the familiar sites. When we look at the dark pattern effect across log domain ranks, we see qualitatively similar patterns. The only difference is that, well, the point estimate and the confidence intervals are both smaller when we are looking at kind of the effect across domain popularity. All right, so for the, how many time do I have?
Until 30, so 8 minutes left.
Okay, awesome. Okay, so for the last for the remaining time, I would like to show you how consumer surplus look like under different data sharing policies. By data sharing policies here, we mean a specific user interface design combined with the website default setting. So here, let me walk you through the key elements in our structural model. And the goal of the model is to enable us to simulate different counterfactuals and also characterize how consumers are choosing across these four options for any given website, and when their choices are potentially influenced by the dark patterns. So as before, a consumer are going to have 4 different options. Option 1 to 3 is each associated with the utility of a sharing outcome, which is the theta. We are going to normalize the utility of sharing no data to 0 just for identification purposes. Each of the option is also associated with an additive cost of going to the settings if this option is hidden, as well as a multiplicative salience term if it's run on top or when it's grayed out. So C1, delta 1, and delta 2, these are going to be our key parameters that characterize the dark patterns. And then there's an option 4, which is closing the window. So what's the utility associated with the closing window? Now, this is going to be determined by consumers' subjective belief about what will happen when they close the window, as well as their utility associated with each sharing outcome, the theta. And the belief, so this is actually our data. So we don't actually have to estimate that. And this is a table that shows the our structural estimate. Now, in the paper, we also kind of have a version of the estimates that are separated kind of across different subgroup of the consumers. But in this table, this is a pooled estimate, and it represents the average preference across all our participants. So let me highlight a few patterns here. So the first kind of like pattern that we see is that the utility associated with the accept all is greater than the utility associated with reject all. And reject all is also more preferred over making any granular choices. This is consistent with the raw choice share that you saw before. The second pattern is that, well, if you look at the cost of clicking into the settings, it is 50% larger than the utility of consumers' most preferred data sharing option. And again, this is consistent with the raw data. So what you saw before is that, well, when we hide an option, consumers are very unlikely to go to the settings. And here we see that, well, this is because the cost of clicking into the setting is too high. It doesn't justify the act of going into the settings and make any choices. So these structural estimates are going to inform our counterfactual simulation. We are in the process of trying to add another counterfactual that also incorporates the global privacy control, but we're still working on that. So for today, I'm just going to show you a comparison across different consent-based policies. So there are three that I'm showing here. The first one, we label it as a US status quo. It has an accept setting design, which means that we are hiding the reject all from the main screen, which is incredibly common here in the States. And the websites are going to default the consumers into sharing all cookies when they close the window. The second one is what we found to be the surplus, consumer surplus maximizing design. It has a neutral interface, and it also has the website defaulting consumers to collect all cookies, sharing all cookies when they close the window. Now, why is this surplus maximizing? First of all, it minimizes the choice friction, which we found to be a huge contributor to consumers' disutility. Second, it also defaults consumers to the option that they prefer the most, which is sharing the cookies. Now, the last one is what we label as the EU norm. Again, it has a neutral interface, but one difference in between the EU norm and the consumer surplus maximizing design is that the EU norm uses a pro-privacy default. And we are going to calculate the consumer surplus, and when doing so, we need to account for consumers' mistakes due to the fact that, well, they may be temporarily affected by the visual salience manipulation, and they may have a belief that is not consistent with what is actually happening. And in order to account for that, we are going to use the Kenneth Chan 2015 formula to separate the behavioral utility and the welfare utility in the surplus calculation. Lastly, we also want to back out the dollar value of this surplus. Now, this is challenging because, as you saw in our experiment design, we actually didn't explicitly elicit the valuation for privacy or the valuation of, well, kind of what is the cost of going over different consent interfaces. Now, what we are doing in our paper is a backup envelope calculation where we take the utility scale of the cost of clicking into the settings, and we find from existing literature, well, what is the dollar value of the opportunity of cost of time clicking into each settings, or another kind of like dollar cost measure that we are using is the search cost. So that is going to allow us to get a a translation from the utility scale to the dollar scale. And we are going to use that translation to back out, well, what is the dollar value equivalent for our consumer surplus measure. Now, for the presentation today, I'm going to focus on the percentage change, which is invariant with the dollar scaling exercise. Okay, so a few key results here. So first of all, if you look at the consumer surplus maximizing design, it increases consumer surplus by 11% compared to the US status quo. And I need to also mention that, well, it also decreases the consent rate by 17%. Now, We can also look at the EU norm. So the EU norm performs worse than the consumer surplus maximizing, simply due to the fact that it uses the pro-privacy default. Now, if you think about the pro-privacy default, it actually has two opposing effects on consumer welfare. So pro-privacy default is a type of default that is more consistent with most consumers believe in when they close a window. So from that regard, it is actually good for consumers when they close a window. However, it also defaults the consumers towards the option that they prefer less, because in our data, most of the time, consumers prefer sharing data versus not sharing the data. So from that perspective, it is also bad for consumers. And in our simulation, we basically found that the second effect dominates the first. Lastly, if you compare the EU norm with the consumer surplus side, if you compare the EU norm with the US status quo, we see that the EU norm is 2% better in terms of the consumer surplus. And it shows that while the benefit of adopting a neutral design dominates the caveat of adopting a pro-privacy side default. All right, I think I am right on time, so let me conclude. We see that the dark patterns that increase the choice friction are more effective than pure visual changes. We also see that at baseline, consumers are more likely to share data with familiar and popular sites. However, the implementation of the dark patterns do not exacerbate this tendency. So it's possible that in data markets, dark patterns could potentially benefit competition by leveling the playing field, which is a bit strange. Lastly, we found that our consumer surplus maximizing design increases consumer surplus by 11% and decreases the consent rate by 17% relative to the US status quo. And the surplus maximizing design is going to have a neutral interface and default consumers to their preferred option. With that, I'm going to stop. Looking forward to the discussion from class and the questions from the audience.